what we're doing is having a look at some locus or loci to try and give the Cartesian equation. What is a Cartesian equation? Yeah, so it's what it would be if we're talking about the xy plane. Okay, so the y plane would be the imaginary part. So there is your imaginary part, and your x would be your real part. Okay, so to do this, what we're going to say is we're going to say this complex number z is the same as x plus iy, because x is my real part and y is my imaginary part, and y and x are just the distance it is from that origin, if you like. Okay, so now what we can do is we can substitute in for z, x plus iy minus 2 plus 5i. The modulus of that, it's the same thing, isn't it? The modulus of that is equal to 1. Okay? Happy with that? What I'm going to do now is I'm going to factorize, for lack of a term, I'm going to put the real parts together and the imaginary parts together. So the real parts, and I'm going to put them in brackets, that's why I'm calling them factorizing. I'm factorizing that. Here's my real component. Happy with that? And my imaginary component is going to be plus I, y plus 5. So that is factorizing, isn't it? Taking the common factor of I out. Happy with that? So therefore my modulus of that is equal to 1. Now how do you find the modulus of something? It's the square root of the two numbers, isn't it? It's the square root of x minus 2 squared and y plus 5 squared. Okay? And if that equals 1, well, does that look like a Cartesian equation that you guys have seen? Do you like the square root of the squares? Or do you just want it to be x minus 2 all squared plus y plus 5 squared equal to 1 squared, which is 1. There is my Cartesian equation. Happy with that? And if you look at these next ones, they're the same sort of processes. First of all, you substitute this part here in. Okay. Next part, you've got to factorize it. We're calling it factorizing because it's not actually factorizing for the real part here, but putting together. And then we're going to go forward from there. Any questions on that one? So the next one, well, the next one's just going to be, I'll make the pen smaller so I can start right a little bit smaller. X plus iy plus 3 minus 2i. So the modulus of that is the same as the modulus of x plus iy minus 4 plus i. What am I going to do next? Yeah, factorize it, put them together. So it's going to be the modulus of x plus 3 plus I into y minus 2. Happy with that step there? Equals x minus 4 plus I into y plus 1. Are you happy with that? Now how do I do my next step is to square it the squares, eh? This is my Pythagoras' theorem, so it's the x plus 3 all squared plus the y minus 2 all squared. Happy with that step?
So you just forget about the I.
Yeah, why do you forget about the I? No, not because it's imaginary. If it was if z was 2 plus 3i, so if it was over here, how would you find the modulus of that? Yeah, you'd do the 2 squared and the 3 squared, eh?
Yeah.
Because it's just the length, and the I is the direction in which it's going upwards. It's going up. So this one's just going up, y minus 2.
Right.
Happy? Do exactly the same thing with the other side. So it's going to be x minus 4. It's that length squared plus the y plus the 1 squared. Alright. What can I do now? Square. We'll square both sides, eh? By squaring both sides, what happens? Yeah, just remove the square excellence, don't I? Look at that. Happy with that? Now what does that look like? 2 circles, yeah. And where the 2 circles meet is going to form a straight line. How does it form a straight line? Well, if we expand these brackets, I'm going to get an x squared. I'm going to get an x squared over here, aren't I? And I'm going to get an x squared over here. Those x squareds are going to cancel out. It's going to get a y squared, it's going to cancel the y squared, and what will happen is things will come out and it will look quite neat in the end. They'll design these so they'll be pretty. So this is just me expanding these brackets. Hopefully I am expanding them correctly. You happy with those brackets expanded? What now happens is I can go, well, that one and that one cancel. This one and this one cancel. 9 and 4 is 13. 16 and 1 is 17. I've just done that to help me with my numbers. So I'm not looking at that one there and that one there, and I'm not looking at those numbers there now. And all I'm left with is trying to collect my like terms and go, well, okay, negative 4y and 2y, that's going to be 6y. Positive 6, negative 8, that's going to be negative 14x. This is going to be a 0 on this side. That's positive 13, that's positive 17, so that's just going to be minus 4. Plus 4, is it? Plus 4, sorry. There's my equation. Can that be written a different way? There's a common factor of 2 there, eh? So I could write it as 3y minus 7x plus 2 equals 0. There's the equation of my line. Okay? Does that sort of make sense?
Yeah.
Okay, and you sort of follow the same steps as what we did over here, eh? It's the same process, it's just slightly different. Okay? So there's two equations there, and this is another equation, or another question from 2017 exam. But pause there and you guys can have a crack at it. This one here, after the pause, really what we're asking you to do is to do x minus 8, x minus 4 plus 2i. Find those two modulus and figure out which of the complex numbers satisfies this equation. So same thing, we're going to say x plus I, y is z. So it's going to be x plus I, y minus 8. The modulus of that is the same as x plus I, y minus 4 plus 2i. The modulus are the same. Happy with that first step? Next step is just to simplify, factorize, group, whatever you want to call it, the real parts and the imaginary parts. Don't need that bracket, but been doing it. So x minus 4, that's my real part. My imaginary parts are going to be like that. Happy? Now what I'm going to do, talk about the modulus. So it's going to be the square of x minus 8. So the square root of x minus 8 squared plus y squared is the same as x minus 4 squared plus y plus 2 squared, and we're taking the square root of that because it's the modulus. Now when we square both sides, we can say that we're talking about that there. And now it's just a matter of expanding and simplifying. X squared minus 16x plus 64 plus y squared. Hopefully that there is right. Please tell me if I am wrong. Do that. Now I've got my simplify that y squared there. Over here this is positive 20, so I can just think about that. And now we're looking at, well, let's put it on this side because I like my y's being positive. 4y is the same as, sorry, not the same as, plus 8x. This negative 8 and this negative 16 combined to be positive 8. 20 minus 64 is going to be minus 44. Is that right? That'll equal 0. Common factor of 4, so I've got y plus 2x minus 11 equals 0. Does that sound right? So therefore, if I'm putting in here, m is y, isn't it? U is 3 plus mi, so y is m and u is, sorry, and x is 3. Can you see that? U is 3 plus mi, it's like x plus yi, so it's just going to become 0 equals m plus 2 lots of 3 minus 11. So that is going to be m plus 6 minus 11, so m has to be 5, hopefully. Happy with that? See that process? What last bit? Okay. So you're happy with that as an equation? So what we're saying now is, well, if we go back to up here, this is what we're trying to solve. We're trying to solve for what particular complex number satisfies 3 plus mi and this equation here. Okay, so that there is an equation of a straight line. Really briefly, does it look like that here? Like that. Y equals negative 2x plus 11. And so when x is 3, what is y? Which particular complex number satisfies that? Does that help you out? Good with that? It's my maths video, but anyway.